Hi everybody, this is Brandon back with Module 5. In this module we're going to cover common errors that occur in the process of heart rate variability analysis. This largely has to do with natural fluctuations or ectopic beats. Ectopic beats are essentially fluctuations within the course of normal heart rate data. They basically just stick out a little bit, or they seem to either be closer to the beat before it or a little closer to the beat after it. In other words, they'll be coded as yellow stars within the Mindware software. These are not always problematic, but in a lot of cases they are. We'll cover when those segments are questionable, when they're easy to interpret, and then we'll go on to cover other issues like drop packets. Drop packets are essentially when data is not transmitted from the software, or from the hardware to the software, and in those cases the data collection is just overwhelmed, and you'll see a dropped R spike. I'll show you what that is in just a couple minutes, and then the last thing is we'll go over arrhythmias and essentially talk about when it's the case of when it's interpretable, when it's manageable to keep that data, and in other cases when it's not. So I'm going to draw from some data that I've collected personally in my own analyses, largely because this is very early on in the process of my research, when there were a lot more problems within the data. From my current analysis with the EMP data, there were not as many issues, so I'm drawing from this data just largely to point out problems. So we'll go ahead. Again, I've made sure that everything's already set within the data analysis program, and so I'll essentially be skipping through a number of segments just to point out where issues come up and where they're pertinent. Okay, so we're going to skip ahead to segment 20 in this file, and you can see here a very manageable case of when a problem occurs in the HRV program. Basically what happened here is, if you look at the respiration data, you can see that there are little jagged edges. What these jagged edges are dropped data packets. Basically what the machine that's collecting the data in your lab is doing is trying to transmit information from a wireless signal. And in some cases that signal is interfered with, and when that happens you get little jagged edges in your actual data. And in those circumstances, which do happen somewhat frequently, some files more than others, it's essentially the issue that you're trying to, your objective is basically to try to eradicate that variation when at all possible. This doesn't require you to look closely at all of the data because it doesn't happen systematically enough that you'll need to do that. However, in this case, it's clear that it is the case. You have drop packets here. You can largely tell from the respiration. This often manifests as like a dropped square line, and we'll see that in a future example as well. Here, what we'll basically be doing is looking at this data and seeing that when we delete it, pulling up here, that we have an R spike, but this R spike doesn't correspond to the rest of the R spikes. In other words, it doesn't go up as it needs to, and although we could depend on that, it's better to not do that when all possible. So basically what we'll be doing is just inserting a midbeat here instead. So we'll move our X cursors around the beat, or around the beats or the R spikes, and then essentially impute a midbeat. I'm going to turn snap to peak and midbeat auto features off, and then just midbeat it in. You'll see that it is just slightly off of the R spike where it would be, and that's perfectly fine in this circumstance. I find it more accurate to actually depend on the midbeat rather than depending on a point that could be off. And if you see this R spike over here, you see a similar circumstance where though we could depend on that, it's best not to. Basically what we'll be doing is moving this over and doing the exact same process, mid-beating it. And you can see that again, it's just a little bit off. However, that little beat could make a big difference when it comes to the RSA. So after fixing both of those points, you see that the IBI channel evens out pretty dramatically, and so we'll just do that, and when we go into our editing notes, we'll mark our editing notes as 2 mid-beats. And in this circumstance, it's perfectly okay to have two mid beats in one segment, just because they're not consecutively next to each other, and they have that gap, or they have that real spike in the middle. So this is a salvageable segment. We'll go ahead and take a look at the next segment of interest. In this circumstance, you have a similar situation where you need mid-beats. Okay, so in this circumstance, it's clear that the R spike is just completely gone. In these circumstances, they're also gone. So while we could save this right here, we'll simply add in a mid-beat. We'll find out that this, in fact, is not salvageable. We can see here that based on these squares, we're not getting a fluid RSP signal, which suggests that we're having drop packets as well. So because of that, we had both of these R spikes dropped. We would not want to assume that this is an R spike. It's very, very, very clear that there's a straight line and that this is not representative of an R spike. There's no QRS complex. There's nothing that suggests that that is actual real data. So in that circumstance, we essentially say that that segment is unusable, and we'll just ignore that, marking our editing notes with a red unusable marker. Going to section 29, we'll see a case where the algorithm has essentially marked a point at two spots in the same R spike. When we look at this initially, we say, oh, okay, it's simply a matter of just deleting this. Oops. However, when you start to look at the data down here, you start to see that there are a number of issues with the RSP signal again, suggesting that there was actually drop packets in here. Because of this, it's actually a wise choice to come in here and delete that point and mid-beat a point instead, just to be safe. In other words, when you see drop packets or questionable data, it's best just to mid-beat and assume that you can fix it that way, rather than depending on a potentially vulnerable signal. We'll go ahead and save that, okay, and you see that that's flattened out a little bit and the RSA changed just a bit as well. So those are examples of drop packets and questionable data that comes largely from the machine communicating with the software properly. Again, I don't think it's necessary that you systematically comb through all of the data, but when you do see circumstances of this, or you see yellow spikes and then see questionable data, it's necessary to look at it in a closer or more detailed fashion. In this case, I'm not going to save the editing file. Typically, you would do that, but I'm going to brush through that. Next, we're going to go to another file. It's okay here. Only my time is from another computer. Just going to bring this up. Go ahead and just check to make sure everything's set. Again, we're good. And then we're going to skip ahead to segment 19. In this case, we have an example of natural physiological variability. Here we see that there are a number of yellow stars. Okay, these yellow stars essentially come up because there's a wider gap between the R spikes in this circumstance than there is the one directly before it or directly after it. When we zoom in even closer, we see that the variability is not huge, but there's definitely a bigger gap here than there is here. This is the paradigmatic case of natural physiological variability. It's not a bad thing that these are marked in yellow, because essentially this means that there's more variability in that participant's heart rate. Variability is not a bad thing. In fact, it's exemplary case of health, or positive health in some circumstances. In this case, I believe it actually is an indication of great health on the participant's part, just for the fact that they have this natural physiological variability. So the yellow stars don't necessarily mean a bad thing. In this circumstance, we would actually keep this segment and consider it a positive. Go ahead and take a look at segment 9. And in this circumstance, we have a case of natural physiological variability that we'll keep. And then we'll also have a case where we have some more drop packets. Okay, so we'll go ahead and take a look at this. And this is clear that it's in just another case where there's a drop packet. We no R spike at all, so we can come in here and fix it with a mid-beat. In this case over here, it seems like it's the same thing. It's clear that that's a drop packet based both on the RSA as well as the ECG signal. So just go ahead and mid-beat that again, and then come back to this one and mark, we'll delete that. In this case, I actually think it's necessary to come in here and take a closer look at this based on what I just told, or what I just mentioned, and see that this is somewhat of a questionable case. So since that is questionable, I think it's necessary to come back in, close up, zoom in on it, and then bring our cursors around and just mid-beat it. And you can see that that's off pretty drastically. And why that's the case, you can see it's kind of questionable whether this RSA is valid or not. So in this circumstance, it just makes sense to mid-beat it. So here in your editing notes, you're going to mark 3 mid-beats, and that's perfectly fine in this circumstance, just because the valid number of R peaks is 77, and as long as we don't come to 10%, which in that circumstance would be roughly 7 or 8, we don't have to throw the segment out. Okay, so we can go ahead and we'll mark our editing notes, and then we'll save it, and we'll go right on to the next file. In this case, we're going to draw from 1024. Check our calibration settings. Go into Analyze. We're going to skip ahead to 17 and 18. And these you can see that there are 1, 2, 3, 4 cases of interest. What we're going to do in this case is zoom in on 17. Here we see that it clearly seems to be a natural R spike. In other words, we see the QRS complex, and it seems to be valid. Even though it's a little bit strange and relative to the other ones around it, it seems that it could be real data, or it should be real data, in fact. So in this circumstance, what would potentially make sense is to mid-beat it to get rid of these yellow stars. However, because it's actual data, we don't want to do that. We don't necessarily want to do that, rather. In this circumstance, I actually think it makes more sense to let an expert decide whether or not that's real data. In other words, corresponding with Mindware or another expert in the field would probably be the necessary step. It may be the case that that these issues are so systematic throughout the data in this particular participant that we may have to exclude the participant altogether. This is just simply a matter of diagnosing what exactly is the cardiovascular mechanism that's causing this. And since you nor I have the actual training to do this, it makes sense to just talk to experts. So if you see circumstances of this, it's best just to mark the editing notes as questionable at the top of the screen in orange, or to mark each segment that has these manifestations of this cardiovascular anomaly as questionable or unusable. In fact, in this, it makes much more sense to call it questionable, because you don't know if this data will be thrown out at all. Okay, so we'll go ahead and take a look at another file. Go ahead and bring this data up, look at a new time. Check our calibration settings. Okay, and then come back over here. So we're going to take a look at this, and this seems to be a similar circumstance to the one we just looked at with the arrhythmia in 1024. This data, as we can see in segment 1 and also in 4 and 22, is pretty consistent, although this one's a bit different. Throughout the data segment, or throughout all of this data though, we see these same cardiovascular anomalies. In some circumstances, they're manageable, in others they're not. In this case, for instance, it looks like it's just a very slight cardiovascular anomaly, or it's just an ectopic beat, if you will. In other words, it's natural physiological variability that is really not harmful to the RSA or doesn't cause any drastic leaps. However, in this case, we see examples where there's a clear drastic increase in the signal, and we don't know if we'll be able to keep it or not. You can also tell this is the case because in segment 20, where we don't have any real issues, we see our RSA at 7. When we go to the next screen, we see that because of these two anomalies, our RSA jumps up 1.5 or almost 1.5 points. That's a huge increase in RSA. Typically, you'll see anything between 5 and 6 for the RSA, depending on what the participant's baseline is. In this case, the jump up to 8.4 is a pretty high RSA, suggesting that these anomalies may be causing a pretty drastic or may necessitate that we get rid of the particular segment. Again, this is beyond our pay grade, so it's necessary that we just mark these as questionable and then allow experts to make those decisions at a later time. Okay, so you'll see as we go through this is the case with the entire data set, and it's likely, I believe, the case that they're going to that we would throw this data set out completely, or this file out completely. So we're going to go to one last file and just take a look at that. Okay. Okay, in this case, we see another case of some natural physiological variability, and this is the perfect case of a border situation where it's not clear either way. In this circumstance, again, it'll be best that an expert makes this decision because as you can see, this seems to be natural physiological, or this seems to be rather consistent, where we see just a slight gap, a smaller gap, and then it continues on with a new kind of variation. You see this is smaller than this, and this does not necessarily mean that there's a problem. Essentially, it could be an issue of there's the heart resetting itself in the case that it's experiencing stress or it witnesses some stimuli. So in this case, it's likely going to be saved data or of real interest to us. However, you can mark these issues as questionable in your research or in your editing notes. And then at least a comparator can come back later and decide whether or not to keep that data or not. So to go back to the main point of this, these common errors or ectopic beats that you come in contact with throughout the course of the analysis are not always easy to decipher, but in those circumstances, it's best to always ask questions and to document those as best as you possibly can. In some circumstances, it might be best to just use your clipping tool. This is available, at least in this circumstance. You can see that I have a snipping tool right here. That's pretty common on all computers in the institute where you'll be conducting this analysis. So in those circumstances, just take a snipping tool and highlight that, save it in the necessary folder, and then contact your supervisor about it. You'll always mark these with questionable in your editing notes, and then you can contact me at brandon.kramer@rutgers.edu or Emily Eddy or the other lab supervisors who are helping you with this analysis. Again, if you have any questions, you can always reach out to us, and we'd be happy to answer any of those questions. And that's all for this last module.